Welcome to This Explainer. Today, we're diving straight into the fascinating, foundational world of brickwork. We're going to learn exactly how to separate the structural champions from the, well, literal dead weight. I am so thrilled you're here, because we're looking at the invisible backbone of the buildings we live and work in every single day. We'll explore how to identify true quality, the rigorous tests these materials have to survive, and the precise methods builders use to put the whole shebang together.
So here is our blueprint for today. 1. Brick basics and dimensions. 2. Testing your brick quality. 3. The 4 brick classes. And 4. Essential prep and bricklaying.
All right, Section 1, Brick Basics and Dimensions. Let's understand the standard building block.
You know, before you can build a wall, you've got to know exactly what you're holding in your hand. And that brings up a deceptively simple question. What exactly makes a brick standard? Because it's really not just some random chunk of baked clay. It's actually a highly regulated, mathematically precise modular unit designed to stack together perfectly. When we talk about a standard modular brick, it has to be exactly 190 millimeters long, by 90 millimeters wide, and by 90 millimeters high. No exceptions. And it's not just about the size either, it's about the geometry. Those edges have to be sharp and square. This level of exactness is absolutely crucial. It's what allows builders to calculate structural loads and material needs with incredible accuracy.
But here's where it gets kind of interesting. There's a big contrast between the bare brick itself and its nominal size. See, a brick rarely sits all by itself, right? It's surrounded by mortar. So the nominal size calculates the actual working space that brick takes up once you add the standard 10 millimeters of mortar, which, by the way, is typically mixed at a 1:6 ratio. When you slap that 10 millimeters of mortar onto the top, bottom, and sides, the working footprint expands to a nice, neat 200 by 200 by 100 millimeters, and that is the actual number architects use when they're mapping out a wall.
Moving right along to Section 2, Testing Your Brick Quality. Let's look at some hands-on tests for durability.
You absolutely don't need a fancy laboratory to test for quality. Your senses work perfectly right out in the field. First off, look at it. You want a uniform, bright copper color, which tells you it was baked perfectly. Second, listen. Strike 2 good bricks together and you should hear a super clear metallic ring, definitely not a dull thud. Third is the drop test. Let it fall flat on hard ground from about a meter up. It absolutely shouldn't shatter. And finally, scratch it. Try to scratch the surface with a nail. If you can leave a mark, well, it's just too soft for your wall. Now, beyond those practical field tests, these materials do undergo some seriously intense mechanical scrutiny. We're talking placing brick samples into high-pressure crushing machines. This basically simulates the immense, crushing weight of a multi-story building pressing down on those lower foundation levels. And that machine testing brings us to a literally non-negotiable metric, 5.50. Basically, absolutely no brick used in construction is permitted to have a crushing strength lower than 5.50 newtons per square millimeter. If it yields under that pressure, no way. It is fundamentally unsafe to bear the structural loads of a permanent building.
Okay, Section 3, the 4 brick classes. Let's decode these quality tiers.
So we can efficiently organize bricks into 4 distinct classes. Let's break this down. First-class bricks are the absolute gold standard. They're table-molded and kiln-burnt, which guarantees those sharp edges and a smooth surface. They're perfect for superior, exposed, permanent work. Then you have second-class bricks. They're also kiln-burnt, but they're ground-molded, making them a bit rougher and slightly irregular. You'll usually see these used for walls that are eventually going to get covered with plaster. Third-class bricks are clamped-burned. That means they aren't as hard, they have distorted edges, and they give off that dull thud when struck. You only really see these in temporary or unimportant structures. And finally, fourth-class bricks. These guys are actually overburnt, giving them a really dark color and a highly irregular shape. You definitely wouldn't build a wall with them. But because they're incredibly hard, they get crushed up to live a second life as aggregate for concrete and foundations and roads.
Now, to really separate those first and second-class bricks from the rest of the pack, we use the water absorption test. This strict rule dictates that when you soak them in water at room temperature for 24 hours, first-class bricks cannot absorb more than 20% of their dry weight. Second-class bricks are capped at 22%. And on top of that, when you take them out and let them dry in the shade, high-quality bricks have to remain dense and uncompromised. That means showing absolutely 0 white salt deposits on their surface.
Which brings us to our final section, number 4, essential prep and bricklaying, putting the pieces together correctly.
All right, before you even think about mixing your mortar on the job site, you absolutely must follow this golden rule. Soak your bricks in water. And we're not just talking about a quick rinse either. They need to be completely submerged for a full 24 hours before you use them.
So, why the mandatory 24-hour soak? Well, it's all about pre-hydrating the brick. If you skip this critical step, a dry, porous brick is going to act exactly like a sponge. It will selfishly suck the water directly out of your wet cement mortar. And mortar desperately needs that specific water content to cure and harden properly. If the brick steals that moisture, the mortar dries out way too fast, which severely weakens the structural bond of your entire wall.
Okay, once your bricks are perfectly prepped and hydrated, the actual building process requires meticulous, disciplined repetition. First, you align your starting brick with the wall using a plumb bob. That makes sure it is perfectly vertical. Second, you arrange the bricks in the same line according to your required bond, and you finish one complete course, or layer. Third, you carefully pack the gaps between the bricks with your mortar. And step 4, this is where the true professionals stand out. You have to rigorously check for line, level, and plumb after every single course. You don't wait until the wall is 3 feet high to see if it's straight, right? You verify every single layer to prevent disastrous leaning down the road.
As we wrap up this explainer, I really want to leave you with a thought to ponder the next time you walk past a brick building. We've seen how standard dimensions, metallic ringing sounds, strict water absorption limits, and meticulous leveling all play a massive part. But remember, the strength of the entire structure truly relies on the rigorous testing and proper placement of every single invisible piece hidden inside that wall. So, how confident are you in the invisible foundations of the walls around you right now? Keep questioning, keep learning, and I will see you in the next explainer.